Every day we're finding new exoplanets and continuing our search for life in the universe. Although we haven't yet found any signs of life beyond Earth, this man, Frank Drake, wrote down a formula for estimating the number of intelligent extraterrestrial races in the galaxy that are attempting to communicate. His formula is called the Drake equation. N is the present number of extraterrestrial races in our galaxy capable of interstellar communication. R is the rate of star formation in our galaxy. Fp is the fraction of stars with planetary systems. Ne is the number of planets per planetary system with an environment suitable for life. Fl is the fraction of potentially habitable planets on which life actually emerges. Fi is the fraction of life-bearing planets on which intelligent life develops. Fc is the fraction of intelligence-bearing planets on which the capability for interstellar communication develops. And L is the average length of time for which civilizations release detectable signals into space. There's nothing wrong with the logic behind the Drake equation. The problem is with the huge uncertainty in the values of several of the parameters. We've no idea of the values of the last four parameters, FL, FI, FC and L, and very little basis on which even to attempt estimates. So the output from the equation, the value of n, is bound to be a guess, rather than any serious attempt to determine the precise number of extraterrestrial civilizations. When Drake first put forward his equation at a conference in 1961, he and his colleagues made some assumptions and educated guesses in order to carry out the calculation. They assumed that on average one star forms per year in our galaxy. 20 to 50% of stars have planets. Stars with planetary systems have between 1 and 5 planets that are potentially habitable. All habitable planets will develop life. All of these will eventually develop intelligent life. And 10 to 20% of this intelligent life will try to communicate with other stars. They estimated the average period over which an extraterrestrial race would send out signals detectable over interstellar distances as being between 1,000 and 100 million years. Using the minimum of all these numbers gives a result of 20, whereas using all the maximum values gives a result for n of 50 million, a pretty broad range. Although astronomy has come a long way since 1961, we still don't have any idea about the value of the last four parameters, and the only way we're going to make progress is to examine in detail a lot of planets and discover on how many of them life and intelligence has emerged. Then we can do a statistical calculation and narrow down some of these values. Recent published estimates for the number of detectable extraterrestrial civilizations in our galaxy have ranged from as little as 9 times 10 to the minus 13, almost zero, and 15,600,000. The range is vast because of the different guesses made for the last four variables. The original purpose of the Drake equation was simply to provide a focal point for discussion among scientists. To that end, it's done its job well. The only way we can ever solve the equation, though, is not by theory or guesswork, but by actually looking for signs of life and intelligence on many worlds throughout the galaxy.